second goal in section 2.2 is we're going to be able to figure out what horizontal tangents are. So horizontal tangents, let's see, horizontal tangent. Tangent is always going to have something to do with f prime or f prime of x or whatever we want to call it. It's always going to have something to do with your derivative. Well, think about the slope of a horizontal line. Horizontal line, if I just drew a quick horizontal line, that slope, let's see, it would rise none and it would run as many as we feel like. So a horizontal line would have a slope of 0. So if that's the case, horizontal means slope of 0, tangent means derivative. We're going to link these two things together to find a horizontal tangent. How are we going to find that? We're going to set derivative equal to 0 and find out what our x values are. So horizontal tangents, let's see. So I'm going to start off with my derivative. So my derivative, dy over dx, pardon me, 4x cubed minus 6x plus 0. There's my derivative. Well, now, if we're going to have that horizontal tangent, we want our slope to be 0. So we're going to take this derivative, we're going to set it equal to 0. So let's take 4x cubed minus 6x. Let's set it equal to 0. Well, now what are we going to do to solve? I'm thinking I'm going to take out a 2x because it's common to both terms. That'll leave me a 2x squared minus a 3 equal to 0. Solving 2x equals 0. There's one of my solutions, or one of my x-coordinates of horizontal tangents. 2x squared minus 3 is equal to 0. How about if we add 3, divide by 2, square root. So x would be a plus or minus, because of the square root, the root of 3/2. So it looks like there are 3 horizontal tangents in this problem. Now the thing's going to get a little bit tricky right here. We're supposed to find the points where this happens. So points, that means I'm going to have to do f of 0. Well, let's see, 0 minus 0 plus 2, that's 2. And then I'm going to have to do f of the square root of 3/2. Well, this is going to get a little sticky, I'm afraid, because that means we're going to take the root of 3/2 to the 4th minus 3 times the root of 3/2, and then we're going to add 2 to it. Well, Mr. Perkins, I can't do that without my calculator. Well, remember, half your AP exam is without your calculator, so we better find a way to get through it. Oh, and I forgot the square right here. That's going to be kind of a big deal. Let's think. Square root of 3/2. Well, if I squared that, that would be 3/2. And if I squared it again, meaning raising it to the 4th power, well, that would give me 9/4. So maybe I can do this without my calculator. Minus 3 times, there's the square root of 3/2 squared. Well, there's a 3/2 plus a 2. Well, 3 times 3/2 would be 9/2. 9/2. Let's see. 9/2. That would be the same thing as having 18/4. And so 9 minus 18 would be negative 9/4. Plus 2, well, 2 would be the same thing as having 8/4. So put that together. How about, after all that's said and done, negative 1/4, if we can make it look like a 4. But then we got to do this again for, oh wait, negative square root of 3 over 2. Whether we do a plus or a minus, we're going to get the same result because those negatives are just going to disappear. So what are the coordinates of my horizontal tangents? My horizontal tangents are happening at the points, let's see, they're happening at the points 0, 2, root of 3/2, negative 1/4, and the opposite of the root of 3/2, negative 1/4. Now, a lot of times those questions, I'll just be asking you to find the x-coordinates where those things happen. But if you need to find the points, just plug them in the function, and maybe it's not as hard as you think. So so horizontal tangents, big concept going forward. We will use this a ton. Horizontal tangents, derivative equal to 0, solve.